Hi, this is Rob Yates, and this is Lesson 5 in Algebra 1 Distance Learning. If you have Ms. Boatwright, Ms. Reynolds, Mr. Still, Mr. McCrae, Mr. Strickland, or Mr. Yates for Algebra 1, then you are in the right place. I'd like to remind you that you can stop this video at any time, you can rewind it at any time, or you can fast forward if you already know all that stuff and you want to get to the end. At the end, we will have today's joke of the day, so stay tuned. Today's learning target is, I understand the properties of generic rectangles. Area is a product and a sum. Do you remember algebra tiles? We use them to create rectangles made up of all the terms in an expression. In this rectangle, they would like us to write the area as a product and as a sum. The product is the area found by multiplying the length and the width, and the sum is found by adding the areas inside the rectangle. So let's just call out the x's and y's inside the rectangle. We have 1xy. We have, 1x squared. It looks like we have 1, 2, 3, 4, 5, 6 x's. And we have 1, 2, 3, 4 y's. And it looks like a total of 1, 2, 3, 4, 5, 6, 7, 8 ones. So, our sum is 1x squared, or we can just write that as x squared, plus 1xy, or just xy, plus 6x, plus 4y, plus 8. All we did is count out what's inside there. You can do it too. Count it out loud. How about the product? Remember, the product is the sides multiplied by each other. This side times this side. So let's try and count out what we got here. This length from here to here is a y. From here to here is an x. And then this is the short side of the x, so it's a 1 and a 2. So we're going to write down plus 2. From here to here, we have an x plus 1, 2, 3, 4 ones, plus 4. So, our product is x plus 4 times y plus x plus 2. And really all we've done is just identify the pieces of this rectangle. All right, when we start with the sum of terms, it's called an expression, we use tiles for each term. What's garbled up here, and you can't really read very well, says, use the tiles to build a rectangle from this expression, 3x squared plus 5x plus 2. Well, I can't move them around, but I can draw a reasonable facsimile. These squares right here are x squareds. So, we're going to draw 3 of them. 1, 2, 3. And just so we know, I'm going to call it an x squared. Now, we have 1, 2, 3, 4, 5 x's. Well, I can slap 3 of them right next to my x squareds, right? I have an x and an x and an x. And let's see, I still have 2 more because I've done 1, 2, 3 x's. So I can do this and this for the other 2. That's an x, that's an x. And then I fill in with my 2 ones. 1 goes here, 1 goes here. There's a 1, there's a 1. So, our sum is 3x squared plus 5x plus 2. We could have got that by counting. But if we look at our rectangle, we can see that down here at the bottom, I have an x and a 1. This is the short side of the x. And along here, I have 1, 2, 3 x's plus 1, 2. So my product is x plus 1 times 3x, that's supposed to be in parentheses, plus 2. X plus 1 times 3x plus 2. And, as Ms. Reynolds has pointed out to us, not every expression can be built into a rectangle. So don't think it's a be-all and solve-all for every problem. When we start with the product and we find the sum, it's called multiplying. And when we start with the sum and we find the product, it's called factoring. Here is a generic rectangle, which we reviewed in lesson 1. Here are our lengths and widths. I have a 6x minus 1, and along this side, I have, I'm trying to make it disappear, 3x. Not going to let me do it. Not going to let me do it. Tell you what I'm going to do is I'm going to move it over. On this side, I have a 3x and a plus 2. And remember that we multiply the intersections. 3 times 6, or 3x times 6x, 3 times 6 is 18, x times x is x squared. 2 times 6 is 12. 2 times 6x is 12x. 2 times negative 1 is negative 2. 3x times negative 1 is negative 3x. So, our sum is everything we've written inside here and a simplified expression of our x's. We have 12x minus 3x. 12 minus 3 is 9. So 9x, I'm going to put my 18x squared out in front, and I'm going to put my minus 2 behind. Here is our sum. And as you may recall, here is our product. Check out what happens when you multiply the diagonals. That is, this way and this way. What is 6x squared times 5x? Well, if you said 30x squared, you either read ahead or you're quick with your multiplication. What is 2x times 15x? Again, it's 30x squared. Generic rectangles, if done properly, always have the same product diagonally. Let's take a look if it works for these others here. All right, what is 5xy times negative 6? If you said negative 30xy, then you got it right. How about what is negative 2y times 15x? If you said negative 30xy, you are correct, and you will notice they're the same. What about down here? What is 12x squared times negative 12? Well, it equals 144. I should say negative 144. x squared. And how about negative 9x times 16x? Do you know that one? I'll bet you do. It is negative 144 x squared. In summary, to find the area as a product, we multiply the length and the width. To find the area of the sums, we just add everything we came up with when we multiplied that's inside the areas of the boxes of the rectangle. And the diagonals of a generic rectangle are always equal when you find the product of those two diagonals. What's next? Log into Khan Academy, do an exercise, or go to student.desmos.com and log in with your class code. Practice worksheet 5, do homework, the Google homework number 5. Remember, you need to do 5 each week. You need to do 3 each week. If you want to do 5, that would be more than 3, which is good. If you want to do 9, that would be awesome. Anyway, today's joke, you're probably saying to yourself, where is today's joke? A mom texted to her son and said, "Hi, son, what does IDK, LY, and TTYL mean?" And her son texted back and said, "I don't know. Love you and talk to you later." And his mom returned a text to him and said, "It's okay. Don't worry about it. I'll ask your sister. Love you too." That's all for today. We'll see you next time.